All right, we're given some information about a graph f, and we're told to match this information to one of these 5 graphs. Let's start with the information that f is continuous and differentiable everywhere except equals -1 and 2. That unfortunately doesn't help us eliminate any answer because every graph seems to have these vertical asymptotes at x equals -1 and 2. So we've already used that information. F has 2 critical points. That means we're trying to find where the derivative is either 0 or does not exist. Now, that would occur where the graph goes horizontal or has a, say, vertical asymptote or a vertical tangent line. Now remember, critical points technically only count if it's on the domain. So the vertical asymptotes don't count as critical points. We're only going to be looking for horizontal tangent lines on the graph. So let's go ahead and do that. I have one horizontal tangent line here. I have one horizontal tangent line here. So that's 2 critical points. So far, so good. I have one horizontal tangent line here. I've got one horizontal tangent line here. So that's 2 critical points. So far, so good. 1, 2. Seems it's got 2. 1, 2. That also has 2. 1, 2. That also has 2. Okay, so it only seems that we have 2 critical points. That only helps us. No, not at all. All right, we're going to use the fact that we have 2 inflection points to get an answer then. An inflection point is where it switches from concave up to concave down, or vice versa. If it switches from concave down to concave up, that would count as an inflection point. And again, that has to be across a point, not across a vertical asymptote. Okay. Here, this graph is entirely concave down. This graph is entirely concave up here because I've got a smile, and I've got a smile here. Now, you could argue that it switches concavity from concave down, there's a frown there, to a smile, but I mean, that happened across a vertical asymptote, so that doesn't count. So this cannot be our answer. We needed 2 inflection points, and we got 0 from this graph. Here we have concave down, concave up. This is very, very tricky. You have to look very closely for this. This is concave up. But these 2 dots over here on the right make it a frown. It's very, very hard to see. But we've got concave up here and then concave down. It's very slight, but we have an inflection point here as it changes from happy face to sad face, or from concave up to concave down. Now, unfortunately, that's still only 1 inflection point, and we wanted 2, so this guy's out. Okay, how many inflection points do we have here? We have concave down here. We've got a frown, but then we've got a smile, so it switches concavity here. And we also have the same phenomenon that we had in the previous graph. It's slightly concave up here, and then there's ever so slight of a change to concave down here. So there's 2 inflection points here. This is probably our answer, but let's go ahead and eliminate all these other answer choices just to be sure, because I think this is our answer. We've got only this 1 inflection point here. It goes from concave down to concave up, and there's no other place where it goes from concave down to concave up or vice versa. This is always concave up. This is always concave down. This is concave up. This is concave up. This is concave up, then it switches to concave down, so we have an inflection point there, but we have no other inflection point besides that 1 inflection point. So these answers are wrong, and it must be this guy is our answer.